Hello everyone, my name is Riel and today I will be discussing about a game I made for our game studio class. So this is basically a tutorial project and an introduction to Unreal Engine's Paper 2D. For this level, I just followed the steps on the Unreal Engine's Paper 2D tutorial and made a custom level which the level design was made by me, and I just utilized all the assets that were provided, and I added an extra mechanic or two inside the game to make it not just like a stiff level design. Let's get into it and see what the game has to offer for now. Let me hit play and it will load our character, and there's like a mission: reach the control room, press E for controls. So if we press E, there's a menu at the bottom left part of the screen, shows how to move with our arrow keys or WASD keys, jump for spacebar, left shift for sprint, and E to show or hide the menu. Alright, so now let's just traverse through the level. So you can see there's not much to do but to just roam around the map. It's just basically a level design for now, and every asset here in this game is provided by Unreal Engine, so it's free, and you will be also able to use these assets if you hop into the Unreal Engine's Learn website. I will provide it in the description box below. So as you can see, we're just traversing this level, and if we fall down the ledge and hit the spikes, we die and we go back to our starting position. And if we go forward and head back and oh no, I fell again. I'm really bad at platforming games, so bad, but at the same time I really like platforming games like Ori or Celeste. There's different platforming games that showcase different mechanics each here. So as you can see, the control room is here. If we fall down to the control room, it will say that we have reached the door and thank you for playing. Press exit to continue, or I mean press escape to exit, sorry about that. And right now the game is paused and we are unable to move our character, so the only way to proceed is to hit escape, and then we are now able to escape our game. Alright, so I'll be discussing how I made this tutorial game. So as you can see, I have a couple of folders here for my tutorial project, and these folders are the top level core folders that I have used for this project. So I have a characters folder, I have a core folder, I have an environment folder, and I have a maps folder. So for the characters folder, it's basically just containing all the animation assets that I used for our main character, which is this Sprite Man here. I should have called him Sprite Man instead of default, but I think it's okay. So as you can see, after the movement, there are a couple of folders that categorizes each action that the player does. So we have an air transition one, we have a fall one, we have an idle, we have jump, run, and walk. So maybe you're wondering why I contained the sprite sheet, the sprites, and the paper flipbook inside a folder. It's because that we can simply filter them out using this filter feature on the top side of this content browser here with the search. So it's pretty easy to filter them out. If you just need something like a texture, you can just filter it out and take it away if you want. So that's basically it for the characters folder. We can add more characters here if we want to, but since we're using the free assets provided by Unreal, we will just have Spriteman or the default character over here. So next will be our core folder, which contains all the blueprints and the fundamental assets that we used in the game development process. So we have a characters folder, we have a game mode folder, and we have a GUI folder. So for the characters folder, we have the blueprint for our characters. So we have two, and the reason why we have two is because in the Unreal Engine tutorial, they featured a top-down to paper 2D game tutorial as well, but for this particular project I used a side scroller, so we won't be getting into the top-down blueprint classes. So we now go inside our character blueprint, and as you can see, I arranged our blueprint, one for movement control, the other one is for animation, and this one is just basically it's uncategorized. It's because it's just like an event where when you hit escape, it will just have you quit the game. So let's start with the movement control. So I have here an eventic event which just checks in every frame to keep everything in sync and in control. So before I discuss this further, I will first discuss our input axis move right, which is viable to our eventic event here. So what does our input axis move right do? So it determines which direction the character is moving towards to. So if we move to the right, it means that we're moving in a positive axis value, and if we're moving to the left, we're moving at a negative axis value. So as you can see, we take the axis value and compare it to 0 if it's greater than or less than. If it's greater than 0, it means we're moving to the right. We're changing the moving right Boolean variable to true. And for this part here, which checks if the character is moving to the left, it's the axis value being compared to 0. So it will, if it's true, then the moving right Boolean variable will be executed as false. So after that information is taken, the axis value will be added as a movement input. So our character will be moving, and it will determine which direction the character is moving to, because we're taking the axis values. It's either positive or negative. But maybe you have a question, maybe what if the character isn't moving? So the answer for that is the default direction of the character is moving towards the right. So they're just facing the right. And for that, the move right and the two values here, as you can see, this one is being compared and this one is compared as well. If they are both false, it will just basically add 0 to the movement input. There's no change at all. But I do confirm that the default direction is towards the right. So now that we have this moving right variable being taken here from our input axis move right event, we move on to our event tick, which has our manage animation event and update walk speed at the beginning of the event tick. It just keeps the animation in sync, like I have written it here, and it also keeps the walk speed of the character in check as well. So if the character started to run, this will automatically be updated within the frame that it's been detected by the event tick. So after that, we then compare the values of the character movement in its x velocity to 0. So like previously, the previous formula here. We also use it using this compare float. So for example, our input, which is our character movement in the x velocity, is greater than 0, means that we're moving towards the right because it's positive. So if we're moving towards the right, it means that we need to have the character facing towards the right. So in order to do that, we force the controller to rotate the character, and we do that by setting the value of our rotator to all zeros, because like I said, the default direction is to the right, so we don't have to add anything or don't have to force anything, just put these values over here and it should be good to go. So once that is done, we have the next part of the execution, which is the equals. So if the character movement velocity x is equals to 0, it will just remain facing to the right, so it's not going to change. However, if it's less than 0, it means that it's a negative value. We would then move over to the left, which means that we need to change our yaw value to rotate it to make the character face towards to the left. So this is our event ticks purpose here on our blueprint. So now that we're done with that, we move on to these three, which is basically just an input action events. So this one is for the run event and this one is for the jump event. So I have bound these events through the use of our keys in our keyboard. For the run, I bounded it to the left shift button. For the jump, I bounded it to the arrow up key as well as the spacebar key. So for the input action run event, it just sets this boolean value here, which is running, and if it's released, or if the left shift button is not pressed, it will just set the running boolean variable to false. So, and same goes with our jump event, where this functions here in our jump event. These are already provided by Unreal Engine. So if our hotkey is pressed for the jump, it will automatically make the character jump, and if it's released, it will stop jumping. So that's that. And for this one, this is the update walk speed, which just checks the character's movement, if it's running or if it's walking, and it will interchange the speed depending on which action is being used. So if, for example, if the character is running, if we press the left shift button, it will adjust the maximum walk speed to 400, and if it's walking, it adjusts the character's movement to 200. So that's the difference between walking and running speed, and that's basically it for that one. As for our animation part of the blueprint, we have a manage animation event, which sets the flipbook animation of the sprites, and it organizes the animation being played in the flipbook. So at the start, we have this is walking function, which just basically checks if the character is on the ground. So if the character is on the ground, it will have the animation selected to be looped. So it will just keep on looking if you're on the ground, and if you're walking, it will just loop the walking animation. If you're standing still, the idle animation will keep on looping. So that's the logic behind this one. And this part here is the update flipbook animation, which just a function that we made to keep on updating the flipbook animation as long as the previous and the new animations are different. They will just compare their values over. I will show it later. Let's just finish this one up first. So for our animation, how would we know if which animation should be used for a specific action? So we have these structs here which pertains to which flipbook animation is going to be used accordingly. So for example, in this first part here, we have our running boolean variable. If the character is said to be running, it will automatically use this true value here, and the true is connected to the run animation of our sprite man. And if it's false, it means that we're going to be using our walking animation. And then after that, there's another struct here that if ever that we're still walking, we do confirm that we're still walking or running, it will just return the true value here, whatever is the one that's correct here in our first struct. However, if we're not moving at all, like we're just standing idling by, it will return a value of false, which has the idle animation put inside. Now, what if the character jumps or is falling from the sky? Will it still have these animations here in our first part of the manage animation? The answer is no, because we have a branch here that once it is determined that the character is not on the ground, it will return a false execution here. And there's another branch that checks if the character is falling or not. So it will check if the character is above ground, and if they are above ground, it will prevent the animation to loop. So it's basically once the character jump, it will not loop, because that will just look awkward. I mean, the jump starts from rising yourself or propelling yourself up. So if it's looping, you will just keep on propelling, and there's no momentum after that. Oh, I forgot to mention that this struct here over the center, the index is actually the get velocity here, and it checks if the player has moved or not. So we have the vector here from our vector is a velocity is actually a vector, so we get that value, and we break the vector and just get the x value from it. And if the x value is not equal to 0, it means that the character is moving. Therefore, we will definitely use this struct here, and whatever option is the correct one, it will be used for our update flipbook animation. If it's not moving though, if it's equals to 0, then it will use this false value, which is the idle animation. Alrighty, next is the jump animation part. So we have this event begin play, which basically just binds these two events here to our game start. So we made two custom events and we bind them over to begin play, so that every time the game starts, they will be automatically be able to appear on our blueprints as well as function as well. So what are these two custom events? So we have the on reach jump apex, which is this one, and then the other one is the on flipbook playback complete. So these are the two events that we binded to event begin play. So first, let's go over to the on jump apex reached. So this basically just updates the flipbook animation once the character reaches the apex. So the apex is the highest point of the jump. So once the character reaches the highest point, it will transition over to the animation that we put inside here, and I believe it's the air transition animation. So once they reach the top, they will slightly move downward. It's like an animation transition, and then once we've jumped, we have this function as well, which is the event on jumped, which is the one resetting the apex notification after every jump, so that it will be able to handle all the animation sequences correctly. So it just lets the apex know that we've already jumped and we have updated the flipbook animation accordingly, and the character movement is going to be updated as well. And after that, after the air transition, we have this on flipbook playback complete. So once this playback is complete, which is it will return true, it will then change the air transition animation, which is the one that is being called when we reach the apex. It will be changed to a falling animation. So there's a slight transition to make it a smoother fall and feel for the player that they're falling, and they can probably also control the momentum using those two animations. It looks pretty nice. If we look at it, let's try it for a while. I'm going to hit play, and there we need to pass this one. So as you can see, once we jump, there's a slight air transition animation. It's not directly going up and down immediately. It's like we're staying up in the air for a while, and there's a smooth transition to fall back down to the ground. Alright, so next is we've added this event here, which is an event on walking off ledge. It just triggers the update flipbook animation function again, and it just changes the animation over to the falling animation every time we're going down a ledge. So it just makes you feel like you're falling off the ledge rather than just walking, and there's the collision can be shown to have like a small gap in between the character and the ledge. So instead of that, we have the falling animation to fix it over. And next we have this help menu that we saw earlier. It's just this code, which is made by an event when the E key is pressed, and once it's pressed, there's a flip-flop that alternates between these two events. For A, we have the help menu to be created, and then for B, we have the widget removed from the viewport. So I'm going to discuss further about the HUD later once we get into it. For now, let's go to our flipbook animation function. So for this function, like I previously stated earlier, it just compares whether the new animation or the previous animation are equal or not. So if it's not equal, which means that there's a change needed to be done, it will then set the flipbook animation to the new animation that is being called, and then it will play that new animation from the beginning of the animation. So that's it for the blueprint character. Now let's move on to the let's move on to the level blueprint. So for our level blueprint, we just basically have the spike platform collision here. So once we hit the collision, which is this one, this box here, I don't know if you can see it, it's like a green box. And if we hit it, the character the character would not be able to move as our input will be disabled, so our controls will be disabled. At the same time, the widget in which like I believe it's like you died, try again, it will show up on the screen, and then after that there will be a slight delay, and after the delay you will be teleported to the spawn location or the start location. The spawn location is where the player start is at. I just took the values of the transform location of our player start and I made it into a variable here for the destination location. And once you are teleported, the game will then re-enable your control, so you will be able to start the level all over again. And next we have these two on actor begin overlaps. They are both box triggers that will trigger the widget that it is assigned to accordingly. So for this one, this triggers the introduction widget that we see at the beginning, which states that the mission is to reach the control room. And then, as you can see, I disabled the input so that the player cannot move while it's displaying this HUD, and there's a slight delay of 1.5 so that the player will be able to use their controls once the HUD shows the press E for controls. So they will be able to press E, they will be able to know the controls. And I destroy the actor after the animation is finished so that the next time you walk through that area you wouldn't trigger this HUD anymore. So it's just a one-time HUD. After it's been executed, it will destroy itself. And next is the end goal HUD, which is basically the end trigger at our control room, which is this green box over here. Once we collide with it, the outro widget will play, and I will show you guys how I made the widget blueprints now. So let's start with the intro. So for the intro, I just have two texts here. They're overlapping each other, but it will make sense because I actually used an animation for them. So as you can see, I have a timeline here, and if I play through it using this slide bar here, there's like a fading animation that you can see. But if we're not in the timeline, it's just basically two texts crumpled together, and it's okay. I mean, it looks fine here, but if it's in actual it's in the actual level, it would be very different because they have their own timings. So our blueprint for that is basically on event construct, which means that once the widget is created, it will play the animation and then it will be removed from the parent widget once it's done. So it will only play once. Next, we have our help menu. So for our help menu, we have the canvas panel animated. It's because as you can see, we're sliding over the canvas panel to make it show like we're sliding the menu over to our screen. So how are we able to move back and forth though? The answer for that is in our graph menu. I mean, our graph editing menu. Yeah, I think it's correct. For this one, we have two events, which is the event construct, which means that this event will be called once the menu has been triggered. And then this is a remove function, which means that it's actually a custom event. So we made this one up. So once we press like if you remember what we did for the blueprints in the character, we have a flip-flop, which means that it will interchange between these two. So it will create and it will destroy over and over again, depending on how many times are you pressing E to trigger that event. So for this one, it will just, if you pressed it for the first time, it will create the widget. For the second time, it will remove, and vice versa. So as you can see, the play mode is forward for the event construct and reverse for the remove. So next, we have the death widget blueprint, and we just basically have a text here with an animation of like a fade in fade out effect, and it's basically the same as earlier. We create a widget, and it's called here in our event construct. Its animation will be played, and it will be then removed from the parent once it's done playing. So lastly, we have our outro, which is basically this text here, which states that we've reached our goal, and we can press escape to exit. So for this one, we have the event construct, and once the widget has been created, on collision, there is a 0.5 second delay. It's just so I could prevent the players to have the character jump over the ledge and die before the game is paused, because it just looks so awkward. So at least if they jump over the ledge, they will just freeze in time while jumping, and it looks much better than them dying and then it will glitch out and everything. So that's my fix for that one. It's not a great one, but it works just fine. I can show you guys what the problem that I was talking about. Let's just walk through the level real quick here. I might have to edit or trim this video out so that it's not too long. It's just, so as you can see, I will jump over here, we can move, and then it stops because the game is paused. So imagine if the player actually jumped over the ledge within that 0.5 seconds. Instead of them actually falling over to the spike collision, they will just stay in midair, which is much better because the you reach the door text wouldn't actually disappear, but the it will collide with the you died text, so that's not nice to see. So that's everything for now. I think I've discussed everything, all there is to know about this game. Like I previously stated, this is just basically me trying to be familiarized with Paper 2D and me trying to come up with level design ideas that the best interests me. This is actually inspired by Fireboy and Water Girl, which is like a game in which you control two players. You can play it with someone, but I played single player, and it's basically your goal is to reach the doors on the somewhere in the level. So this is my take on that. So you start somewhere and you need to traverse the map in order to reach the control room. Unfortunately, I didn't have any other implementations added, but this is just a practice project for me. I do have a custom project that I will upload later tonight, and I hope you will be able to join me discuss my custom project. It's really out there. I put a lot of implementations there, and I'm really passionate to discuss how I made those things. And I'll see you guys on the next video. Thank you for watching. Goodbye.